Now the important point in the hyperbola, after our discussion with the point lying inside, away from this, we have another interesting point, that is equation of a tangent which I have shown to you, p x1 y1 s1 is equal to 0. We have equation of the normal. Equation of the normal, you can see, for a tangent when you draw, this is the normal and this part normal equation. This is your tangent equation. Tangent equation already we have shown s1 is equal to 0. That is x1 by a square minus y1 by b square is equal to 1. And in the case of normal, what is the difference between a normal and the tangent? In the tangent, s1 is equal to 0. See, the slope of the tangent is m1, the slope of the normal happens to be normal. If this happens to be m2, then product of the slopes, m1 tangent slope and the normal slope, the product of them is always equivalent to minus 1. By looking at this, as you have studied in the first year, the product of slopes is equal to minus 1 means they are perpendicular to each other. So tangent and normal, always they are perpendicular to each other. But both of them are intersecting at the same point, they are passing through the same point P. Let us say at P x1 y1, if you draw a tangent, you can also draw a normal exactly at the point P x1 y1 in this format. Friends, when we see the normal equation, the slopes are minus 1. How do we extract the slope from this? As all of you know, it is b square x1 by a square minus y1 by b square into y1 by b square into a square y1 minus a square b square is equal to 0. Then we take the slope of the slope, if you want to know, m2. Very simple, minus of a by b, minus of capital A by capital B, that is coefficient of x by coefficient of y. So we write b square x1 by a square and we derive in this form. This is how we take in general the slope of a tangent, slope of a normal. That is, any line, for example, very simple, you please understand, ax plus by plus c is equal to 0 is there. What is the slope? All of you know, minus a coefficient of x by coefficient of y. So we write minus of a by b. This is what is the slope of any line. The perpendicular line to this will be how much? B by a. Perpendicular line slope will be b by a. The product of these two, minus of a by b into b by a, they get cancelled and you see minus 1 you obtain. This is the simple logic, this logic of which you have studied in pair of straight lines and straight lines, and the first year, the same way it applies to the tangent as well as to the normal. So normal equation, please write down. Normal equation you can write in this form. A square x by x1 plus b square y by y1 is equal to a square plus b is equal to a square plus b square. Parametric equations, and then we have equations of tangent at theta. Parametric equations, how do we write in the case? For example, as you have seen in ellipse, parametric equations we have come across in the ellipse. What are called parametric equations? You know, parametric equations in the case of x is equal to 81 square, y is equal to 82 square, 281. X is equal to 81 square, y is equal to 81, like this we have come across in the case of a parabola, same parametric parabola, and we have come across in the case of ellipse the parametric equation. Ellipse, we have come across x square by a square plus y square by b square is equal to 1. We have come across x is equal to a cos theta, y is equal to b sin theta. If you observe here parametric equations, you know on the day when we have done our ellipse part, in the case of x, a cos theta, that means a square cos square theta divided by a square plus y b sin theta. When we have substituted the same, b square sin square theta divided by b square. If you see the wonder of this b square and b square, a square will go away. As we have seen in trigonometry, cos square theta plus sin square theta is equal to 1. Left hand side is equal to right hand side. Equation is obtained. Parameters we have used. Parameters means what? Instead of the original variable value x and y, we substitute a suitable value into the expression or into the equation in the place of the variable x as well as y. So when we substitute, this equation must be satisfied. When the equation is satisfied, we claim that these are called parameters. So these parameters, how they are existing for parabola, similarly for the ellipse, we also have parameters for the hyperbola. Friends, you can see the hyperbola parameters, how they can be taken into consideration. Parametrical equations for hyperbola. Parametrical equations. Parametric equation. For hyperbola. For hyperbola. In this, x is equal to a secant theta, y is equal to b tan theta, you can always write. The reason is known to you. We have x square by a square minus y square by b square is equal to 1. Why I am saying known to you? Because you are masters in trigonometry already in first year you have completed. Now you have come to the second year and you have experienced a lot of trigonometrical equations. So by substituting in the place of x square by a square minus y square by b square is equal to 1. In the place of x, if you substitute a secant theta, it is a square secant square theta by a square minus y square, as you have seen, b square tan square theta divided by b square. This b square is gone, a square is gone, right hand side 1 sustains as it is. As you look into this, we have secant square theta, we have minus tan square theta, and the net result is 1. Since you have studied in the trigonometry standard identities, 1 plus tan square theta is equal to secant square theta. So as you have come across this is fulfilled here. Therefore, fulfillment, once it is coming here, we can conclude that it is nothing but the parameters for this. After this parametric equations, we have equation of the normal on the hyperbola in terms of parameters. In terms of parameters, what is the hyperbola normal? I have shown to you a normal equation in general in an ordinary form. But now the same equation of normal to the hyperbola with the parameter. With the parameter we write. With the parameters we write normal equation. With the normal equation we write ax by secant theta, as we have seen, in the place of x1, a square, you can write equation of the normal at the point theta, ax by secant theta plus by tan theta, by tan theta is equal to a square plus b square. This is the equation of the normal at the point theta, and also a necessary and sufficient condition for a line to be tangent. For a line to be a tangent for a given hyperbola, what is the necessary and sufficient condition? A necessary and sufficient condition. A necessary and sufficient condition. A necessary and sufficient condition for a line to be a tangent to the hyperbola. So S is equal to 0 hyperbola. So necessary and sufficient condition you can write in this form. C square is equal to a square m square minus b square. C square is equal to a square m square minus b square is the necessary condition for a hyperbola. A necessary condition. What is the line? Given line is, you can write given line y is equal to mx plus c. If this line wants to be a tangent for the hyperbola, the necessary and sufficient condition is c square. You can write this one in the form of c square, constant part. C square is equal to a square into m square, the slope square, minus b square of the hyperbola. Then y is equal to, you can also write in the c value as you have seen. C square is equal to a square m square. What is the c value? Square root of a square m square minus b square. So this part under the root will be substituted. Therefore y is equal to mx plus c. That means square root of a square m square minus of b square. We write. This is the absolute condition for a line to be a tangent. C square is a square m square minus b square, and we represent c value in the given straight line equation. The given line in the straight line equation. Once we see into this part, we have plane of hyperbola s is equal to 0, the polar of p. As I have told you, tangent equation we have seen, chord of contact we have seen, chord of contact, and now polar. Polar equation is also known as S1 is equal to 0. Friends, when we talk about S1 is equal to 0, all the three do carry the same S1 is equal to 0 as a representation for a straight line connecting to the hyperbola. So we have S1 is equal to 0, and finally the pole of the line. Now polar you have seen, the polar's pole. If the polar happens to be Lx plus my plus n is equal to 0, polar, let us see, polar. Polar is there for ellipse, polar is also there for circles, and polar is there for system of circles. Now polar is seen in parabola, ellipse, and now finally we are going to see the polar last time for the hyperbola. Polar is known as a set of points. Polar is a straight line. Polar is a straight line. It's a set of points and which passes through the point of intersection of the pair of tangents drawn to the curve. Let us see that polar will have a pole. So pole of the line Lx plus my plus n is equal to 0. With respect to the hyperbola. With respect to hyperbola, s is equal to x square by a square, x square by a square minus y square by b square is equal to 1. To this hyperbola, the polar is known as, you can see, identify L, M, N. They are going to be useful with a negative sign, minus a square L by N, comma, b square M by N. So this will be polar, and you know, a basic condition is n should not be equal to 0, because n happens to be 0, what will happen? You all know, if the denominator happens to be 0, it is going to be an infinite value. So friends, we have seen some of the important conditions, synoptical, interesting part of these things. Now we will go into the general applications and which are given to us in this step. Exercise 5A. One question, you can see, one focus of hyperbola. If you see the first question, the focus of the hyperbola is located. The focus of the hyperbola is located at the point 1 comma minus 3, and the corresponding directrix line is given to us as y is equal to 2. So you can understand y minus 2 is equal to 0. Find the equation of the parabola. Find the equation of the parabola. Find the equation of the parabola whose eccentricity is equal to, given to us as 3 by 2. This is the question. We have, if you look into the solution part, our directrix is here. Our point on the parabola, our point on the hyperbola, P, is identified as P x1 y1. The directrix is the line. From the fixed line and from the fixed point P, we have dropped a perpendicular PM. And the equation of the line is y minus 2 is equal to 0. You all know. It is given to us. Now, the fixed point focus, S is 1 comma minus 3. So as I told you in the beginning of today's class, SP by PM is equal to E. So SP is equal to E into PM, and you know SP square is equal to E square PM square. E square PM square. When we identify this particular part, x minus 1 whole square, as you know, when you are talking about SP square, let us do it here. Practically, besides these questions and tablet, x1 minus 1 whole square. And similarly, x1 minus 1 whole square. Similarly, y2 minus y1 plus 3 whole square is equal to E square, as I told you, E square PM square. E has been given to us. E is equal to 3 by 2. E square PM square. 3 by 2 whole square into PM square, perpendicular distance to the line. From this point to this line, if you observe here, 1 comma minus 3. SP square, we have calculated E square PM square, perpendicular distance to this line. This point is x1, but there is no place to be substituted. Friends, you can see when y minus 2 is equal to 0, you can write 0x1 also, or 0x. In the place of this 0x, if you substitute x1 into x, that is 0 into anything. So you can write 0 into anything is 0 plus y1 minus 2 whole square under the root. Coefficient of y1 is 1 square, coefficient of x1 is 0 square, and there is a square for it. So friends, when we simplify this equation, x1 minus 1 whole square, x1 square plus 1 minus 2x1, similarly y1 square plus 9 plus 6y, which is absolutely equivalent to 9 by 4, and y1 minus 2 whole square, all of you know, y1 square plus 4 minus 4y1, it is in the form of a minus b whole square. We are expanding this, y1 square plus b square, 2 square, minus 2ab part, minus 2 into y1, that is minus 4y1, whole divided by square root of 1 square is there. Square root goes away because there is a square on the top. Friends, when we see this part is calculated as x1 square plus y1 square minus 2x1 plus 9 and plus 1 reduces to plus 10, and also plus 6y part is there, and 9 by 4 multiplies to y square minus 4y1 plus 4. So on simplification, bringing everything by cross multiplication to one side, you get from here 4 into you get x1 square y1 square, 4 into x1 square y1 square, and then minus 2x1, and then plus 6y1 plus 10 multiplied to 9, denominator 4 is cross multiplied here, 9 into y square minus 4y plus 4. On simplification and bringing to one side, we get 4x1 square minus 5y1 square and minus 8x1 and plus 60y1 plus 4 is equal to 0. So focus of P x1 y1. Now you know focus of P x1 y1. Writing the locus part of the equation. So what we do is we eliminate the suffixes x1 and y1 square. You write 4x square minus 5y square minus 8x plus 60y plus 4 is equal to 0. So this is our required equation for the hyperbola. This is required equation of hyperbola. Friends, what happened in this problem? Hyperbola. We have been given a focus is located and a point is located. Focus is located at the point P1 comma minus 3, which we have indicated here S. And a point P is considered as x1 y1 on the curve of this hyperbola. And the distance from this point P to the directrix, which is given to us as y minus 2 is equal to 0, we have taken as PM. Now SP by PM is equal to eccentricity. So SP by PM square we have derived, as you have seen. SP by PM is equal to E by cross multiplication. E into Pm squaring on both sides, Sp square is equal to E square into Pm square. Now as you know, Sp square, distance between the point and the focus. Focus is 1 comma minus 3, point is x1. We have calculated the distance x2 minus x1 whole square y2 minus. And then E square part is there. E value has been given to us in the problem itself. The equation of the parabola, that is hyperbola, with the eccentricity E is equal to 3 by 2 is given. So the 3 by 2, when we substitute, it is going to be 3 by 2 whole square, that is E square 9 by 4, and the perpendicular distance from the focus, that is from this point to this P, x1, y1, a point on the curve, to the directrix. That is called your PM. PM is perpendicular distance. We have calculated y1 minus 2 whole square divided by this. Now, when y1 minus 2 whole square is expanded in this form with 9 by 4, when we have calculated, here this is y by y1 square. In fact, y1 square 4 minus 4 y1. It is cross multiplied with 4 the left hand side, and the numerator part 9 is multiplied to y1 square plus 4 and minus 4 y1. So this part, if you take minus 4 y1 square. So y1 square minus 4y1 plus 4 are multiplied, and now after expansion all of them are brought to one side and the right hand side part becomes 0. And once we calculate focus of the point px1 y1 with the locus, we write in this form, and that is 4x square minus 5y square minus 8. This is how we simplify the general equation, general application of the one of the points.